Welcome back to my channel and welcome to my SSCE mathematics series from zero to guru. In this video, I'm going to continue from where we stopped on simple indicial equation, and here I'm going to explain how you can solve indicial equation that is more complicated. So in the last video, I gave you some hints on how you can solve indicial equation. So, and I said it is not difficult. What we have to do is to apply some of the laws of indices, some of the rules of indices, apply them and combine them together. So, okay, now let's continue. Let's say I have this type of question. Example. Suppose I have 3 raised power x. If 3 raised power x minus 12, 3 raised power 2x minus 12 multiplied by 3 raised power x plus 27 is equal to 0. Find x. Find x. So you can see this is more complicated indicial equation. So if you think carefully, you will see that it is very difficult to use some of the rules of indices unless you break this equation down. How do you do that? You will see that this is 3 raised power s, then I can also have another 3 raised power x here. You understand now? And you will observe that I cannot use any of the rules here. Okay, let's see what I can do. Let's say I let my p to be 3 raised power x. If my p is 3 raised power s, remember before I can rewrite this as 3 raised power s, everything raised power 2, right? Minus 12, 3 raised power s plus 27 is equal to 0. Now that I make my p to be 3 raised power s, this is going to be p squared minus 12p plus 27 is equal to 0. Yeah, can you see it has led to what? To a quadratic equation. You know the one we did in the last video led to simple equation. That's why we call it simple indicial equation. This leads to quadratic equation. And don't forget, by quadratic equation, how many roots are we going to have? We are going to have 2 roots because it is an equation of degree 2. And when you have equation of degree 2, you are going to have 2 roots. If you have equation of degree n, you are going to have n roots. Okay, now let us solve this. So quadratically, don't forget your factorization method. You can make this your a to be 1, your b is equal to minus 12, then your c is equal to 27. Then you find your AC is equal to 27. So then you now think out of the factors of 27, you know the factors of 27 are 1, 2, 3, 9, and 27 itself. And don't forget for each whole number, there are 2 pairs of factors, such a way that when they multiply themselves, you are going to have 27. For example, I can have 127, you know 120 times 27 will give me 27. So then 2 is not there, sorry. Then you have 3 times 9, which is 27. You understand now? So you now say, what is such number out of these 2 pair, whether the positive or negative of it, such a way that when you multiply it by themselves, so you are going to, when you multiply them together, you are going to have 27, and when you add them, you are going to have minus 12. You know it cannot be this pair, it is this pair, that is 3 and 9. You can say 3 times 9 will give me 27. Likewise, minus 3 minus 9 will give me minus 12. Now you now substitute it here. And you are going to have p square minus 3p minus 9p plus 27 is equal to 0. Then you group them. You can see that p is common here. If you take p out, I'm going to have p minus 3. Also, minus 9 is common here. Then I'm still going to have p left here minus 3. You can still see that p minus 3 is also common when you factor it out. Then what do you have left? P minus 9 is equal to 0. If the product of 2 numbers is 0, then either of the 2 number is 0. Therefore, either p minus 3 is equal to 0 or p minus 9 is equal to 0. That will give me p is equal to 3 or p is equal to 9. Yeah. But don't forget, we made our p to be what? So to be 3 raised power x. You understand now? So you have to recall that p is equal to 3 raised power x. Now I now know the value of my p. And I say when p is equal to 3 raised power x, when p is equal to 3, you know I have two values of p, 3 and 9, right? So when p is equal to 3, you now substitute it here. Then if you make the substitution, I'm going to have 3 is equal to 3 raised power x. You understand? And don't forget this same thing as 3 raised power 1. You can just equate the base. Equating the base, this guy will cancel each other, then I have s equal to 1. Likewise, when your p is equal to 9, then I'm going to have what? This is my equation. 9 is equal to 3 raised power s. I'm going to rewrite this in terms of 3. That's 3 squared is equal to 3 raised power s. And this guy will cancel this. And I have s equal to 2. You understand now? You have s equal to 2. You now conclude by saying, therefore, s equal to 2 or s equal to 1. You can see it is very simple. We can test that in the question. Let's say I put, I have 3 raised power 2x minus 12, the 3 raised power s plus 27 is equal to 0. So when s is equal to 1, if you substitute the value of s to be 1, this is going to be 3 raised power 2, that's 9 minus 12. This is 3, right? Plus 27. So that's 9 minus, so this is 36 plus 27. You observe that 27 plus 9 is also 36. 36 minus 36 will give me what? So will give me 0. So likewise, you substitute to it, you are going to have it like that too. You can see it is very simple. Okay, now let me give you another example. Example. If 9 raised power x minus 10, 3 raised power x plus 24 is equal to 0, find x. Find the values of x. This is very simple. You follow the same approach with what we used the other time. This 9 raised power x minus 10 into 3 raised power x plus 24 is equal to 0. It is not difficult to do, is it? No. So you will see that all your rule here, you cannot apply it except that you can say this is 3 raised power 2x, right? Or you say 3 raised power 2, everything raised power x, since 9 is 3 raised power 2. Okay, now how do you proceed? So that is not, you don't know how to proceed. So what you can do, like I've explained the other time, but before we do that, let us rewrite this. This can also be 3 raised power s, everything raised power 2, minus 10 raised power 3s plus 24 is equal to 0. And I can still say let my p is equal to 3 raised power x. So if my p is equal to 3 raised power x, so then wherever I have p here, I substitute with the value of what? 3 raised power x. Wherever I have 3 raised power s, so I have what? I put p. Then this is going to give me p squared minus 10p plus 24. That has led to what? Quadratic equation again. And don't forget, since quadratic equation is equation of degree 2, then we are going to have how many roots? 2 roots. So don't forget how I did it the other time. Your A is 1, B is minus 10, C is 24. So then your AC is equal to 24. Think of the pairs of what? Of factors of 24. Have 1, 2, 3, 4, 6, 12, 24. You have 124, 2, 12, 2, 12. What else? Yeah. So sorry, we have 8. 3, 8. Then we have 4, 6. Yeah. So what is, out of these pairs, what is such number that when you multiply the two numbers together, you are going to have 24, and when you add them, you are going to have -6. You can see that it is this pair because 4 times 6 is 24. Sorry, -4 times -6 is 24, and -4 minus 6 is also -10. Then you now substitute it here. I have p square minus 4p minus 6p plus 24 is equal to 0. If that is the case, then I can group them. I can easily group them. So this is going to be p. You can group them in two like this. Then this guy, I have p minus 4. So then what do you have in common here? 6 is also common, right? P minus 4 is equal to 0. You understand? So then I have my p minus 4 common, p minus 6. And two number is said to be 0 if what? So if their product, if either one of the numbers is 0. So then you have p is equal to 4 or p is equal to 6. Hope I didn't make any mistake here. Let me check it. Yeah, no mistake. Okay, let's proceed. So then p is equal to 4 or p is equal to 3. Then you now come back to your, remember before we have that our p is equal to 3 raised power x. You understand? You have p is equal to 3 raised power x. Then you now substitute it together. So that is, let p is equal to 4. Then I'm going to have 4 is equal to 3 raised power x. Yeah. You can see that you cannot rewrite this in this form. You understand? Sorry, the question I took it offhand. So likewise, for p is equal to 6, then you are going to have what? C is equal to 3 raised power s. But suppose instead of 4 here, suppose I have like 9, for example. You can just equate the base. That will give you 9 is equal to 3 raised power s. So that's going to give you 3 squared is equal to what? Is equal to 3 raised power s. Then your s is equal to 2. So that's that. Actually, you can also solve this, but I don't want to bother you because we've not gone to logarithm. You can apply your logarithm. So you can apply your logarithm. So from according to logarithm, if 4 is equal to 3 raised power s, so that is when you have a raised power n raised power a base x, the same thing as a is equal to n raised power x. You understand now? So, but we've not gone there. I'm sorry for the type of question. So that's how you are going to solve it. So if it is something you can express as, as number of, in terms of x, so then it is fine. So you can just equate the base. But for this one, we have no, so we have what? No such solution for x. You understand now? So you can say no such solution for whole number x or natural number x. Yeah, so that's that. I'm sorry for the type of question. I didn't solve it before. So that's that. If you understand, please don't forget to check many questions that are related to this, solve it and see if you can solve it by yourself. So if you have any question, do not hesitate to post them on the comment section. And if you've not subscribed to my channel before, please don't forget to do so and inform your friend to do so. Thank you so much and see you in the next video.